Hello HMS modelers. I'm Greg Karlovitz, Senior Hydraulic Engineer at the U.S. Army Corps of Engineers Hydrologic Engineering Center. And in this video, I'm going to go over grid data, which are a type of shared data component in HEC-HMS. So what exactly are grid data? Well, the definition of a grid is that it's spatial data that exists on a regular lattice, or as a synonym, raster data. A regular lattice implies that the cell size is the same for the entire data set and that the cell location can be referenced from an index location, for example an origin, like the coordinates 0, 0, and then offset from it, row 10, column 26. If you work with GIS frequently, then you're already familiar with raster data sets. That's exactly what we're talking about with grid data. The value for each cell is constant across the cell. For continuous data, usually numeric data that can take on any value over a range, the cell usually represents the average value of the true information. For example, a grid of elevation data is likely to represent the average of the true elevation over the grid cell. In traditional HMS modeling, grid data are most frequently used to model precipitation boundary conditions, such as radar-based precipitation measurement. As HMS capabilities have grown, additional types of grid or raster data have been added to address modeling needs. An important distinction exists between grids and grid sets in HMS. Grids are static. They're an unchanging snapshot and are not associated with any sort of time. The example above shows an impervious area grid, which stays constant with respect to time. These data sets contain a single grid. Yes, in real life, impervious area amounts can change, but HMS cannot currently model time-varying impervious area. Grid sets are not static and are what you would use to represent boundary conditions like precipitation or temperature. The grid set contains many grids, and each grid is associated with a date and time. The example here shows a temperature grid set, which might contain a set of grids that are observations of surface temperature taken each hour. There are two ways to create a grid data component. The first is to choose Components, Create Component, Grid Data from the menu at the top. You'll see a dialog box like this in the lower right. Choose the type of grid in the drop-down menu, then give it a name. Pressing Create adds a new grid data object to the Watershed Explorer. The second way is to go through the Grid Data Manager, which can be accessed in the Components menu. The Grid Data Manager allows you to see all the grids that have already been created, organized by type. It also lets you create new ones, or copy, rename, or delete existing ones. Pressing the New button will launch the same creation dialog as the creation option from the previous slide. Depending on whether you're working with a grid or a grid set, you can link an HMS grid component to different sources of data. In any case, HEC-DSS can be used as a data source for a grid component. HMS underneath the hood is always dealing with HEC-DSS for data storage, so this format is always applicable. For grid sets, this is the only type of data that currently can be used. However, utilities for converting data from one format, for example NetCDF, HDF, and so on, to HEC-DSS are available and will be discussed in just a bit. For grids, there are also two formats of raster data that can be linked up. GeoTIFF is the most common format used for these types of data. ASCII grids are mainly provided as an option for precipitation frequency grids, but certainly can be used for other data types if that is how the source data are stored. Often the data we want to use for gridded boundary conditions are in a format that HMS cannot directly use. Commonly, NetCDF or HDF is used to store high-dimensional data, such as meteorologic or climatic data. Many times, each time step of the data is in a separate source data file, meaning that a day's worth of hourly time step data might be in 24 files. In order to get HEC-HMS to use these, they need to be placed in a DSS file with the correct convention. Then, you'll need to create the correct type of grid data component, and then link the DSS file you created to that component. HEC-HMS now features a tool for importing grid data from a variety of formats into the HEC-DSS format. It is able to handle one or many files as inputs, filter down to the variables of interest, clip the grid domains to a user-specified spatial extent, deal with projecting the grid data, and handle resampling the grid resolutions. It is available by going into the File menu, dropping down to Import, and selecting Import Gridded Data. The following slides will walk through a simple import using this tool. On the first screen of the Import tool, you could select as many files as you want to import into the DSS file at the end. Select the Browse button on the right and add the files. Supported formats will be shown in the browsing dialog. Some data are contained all within one file, as is in the case shown here. In other cases, the data is spread out over a number of files. In either instance, you can add those source data files to the wizard. The variable selection step is important in case the source data store multiple kinds of data at a time. Some data have a convention that store latitude and longitude as grids as well, and we don't want to import those. In this case, we have selected the PRCP or precip data variable and moved it to the right side, meaning any data with the precip variable type will be imported. The import utility will automatically interpret this as precipitation data. Many types of data are supported with this import utility, which recognizes most of the common abbreviations or variable names for gridded meteorologic data. The third step handles all of the spatial processing. Using a clipping data source can drastically reduce the size of the output file, especially when the source data covers a much larger spatial extent than the project area that you're trying to model. One handy way to get a clipping data source is to export the watershed polygon shapefile from your HEC-HMS watershed delineation. The target wicket controls what projection the output data should be in. If you click the Browse icon, you could browse to a source of spatial data and use the projection information for that dataset. Or you could select the globe icon, which will give you some built-in options, such as SHG, which is commonly used for HEC-HMS models in the United States. The target cell size controls how the data will be resampled. This is the cell size that the output data will be in, measured in meters. The output size is dependent on the resolution needed for the project. Use the cell size that is smallest the size of the input data. Coarsening the resolution of the data will reduce your file size. Typical options are selectable if you select the grid icon to the right of the box. A typical resolution for HMS models that takes into account the typical resolution of gridded data is 2000 meters. Finally, the resampling method controls what method HEC-HMS will use to convert the source data to the target data. For meteorologic data, bilinear is typically adequate. Finally, choose a destination for the data import. This can be an existing or a new HEC DSS file. Then, specify the A, B, and F parts of the target DSS paths. The importer will automatically handle the C, D, and E parts based on the import data. The final step is to create a new grid data component and link it up to the DSS file you just created. You can browse to the DSS file by choosing the Browse icon next to the DSS file name. Then, link up the correct DSS path name by using the little Browse icon to the right of the DSS path name text box. This has been your introduction to grid data, a type of shared data component in HEC-HMS. For more information, see the HMS User's Manual online, the HMS Tutorials and Guides online, or other tutorials and guide videos in this series. Thanks, and have a great day.